Now that we have some grasp on functions in general, we're going to start looking at different families of functions. The family you're probably already most familiar with, which will be the first family that we study, are linear functions. You can find information in your textbook on linear functions in sections 2.3 and 4.2 if you're looking for word models, for word problems, models, real-world situations, and then 4.1 if you're looking for linear functions more in abstract. There also are some things in your textbook in sections 2.1 and 2.2 on this as well, but 4.1 really goes into the most depth. As always, please feel free to jump to a particular part in the video by looking in the description at the different timestamps. If, for example, you already feel comfortable with slope but want to know more about slope-intercept form, feel free to do that. Or if you want really more of the in-class experience where we go over everything together, just go ahead and watch the video in order, but take active notes as always. Slope of a line is a special case of finding an average rate of change where the average rate of change is the same throughout the entire function. So in particular, we're still looking in change in output divided by change in input. A lot of times we conceptualize this as change in y divided by change in x. You might have also heard rise over run in the past. That's the same idea since y has to do with the rise, x has to do with the run. y2 minus y1 over x2 minus x1, or you could always label it the exact same way we just did an average rate of change of f of x2 minus f of x1 over x2 minus x1. However you want to phrase it, as long as you are looking at the change in y divided by the change in x, you are fine. The place that people mess up the most is by using y2 first up here, but then accidentally using x1 first down here. So just make sure that whatever point you choose to list first on the numerator is the same point you choose to list first on the denominator. So let's take a look at a specific example. So if you're given a physical graph, there's a couple different ways you can go about calculating the slope. If you notice in particular that we're counting by ones on the x's and counting by ones on the y's, it may just be easiest to count it from the graph. And by that I mean you can count that we went up 1, 2, 3 on the output, over 1 on the input, so our rise was 3, our run was 1. 3 over 1 simplifies to 3. And then you just want to double check your sign, so it looks like from left to right we're going uphill. This is an increasing function, so we just go ahead and leave it as positive 3. That's completely fine. The only thing is if you're going to visually count it like that, you want to make sure that your axes are actually counting by ones. If they're counting by something else, you want to count accordingly. Another way that you can do this is by just using the formula and still finding it algebraically. So we'll note that this first point, x2, y2, for example, occurs at 2, 8, because we went over 2 up 8. Our second point occurs here at 1, 5, since we went over 1 up 5. And then we can just plug into the formula. So our y2 is 8, minus our y1 is 5, over our x2 is 2, our x1 is 1. 8 minus 5 gives us 3, 2 minus 1 gives us 1, and that gives us 3. The advantage of using the formula over purely looking at it visually is as long as you don't accidentally use a different y2 than an x2, like that these actually match up to the same point, you won't mess up your sign. So if you're just doing it visually, you always have to kind of double check your sign by hand. If it's increasing, it's positive. If it's decreasing, it's negative. Versus if you use the formula, your sign will just follow with the arithmetic. Let's practice using the formula just a little bit more. So go ahead and pause your video and try out both of these, and then we can compare together. So a lot of times when I'm finding things algebraically, I like to go ahead and label an arbitrary x1, y1, and an arbitrary x2, y2. It is completely fine if you flip-flop these, as long as you're consistent. So then we can find our slope by noting that that's the change in y divided by the change in x, the difference in output divided by the difference in input, and then we plug and chug. y2 is 3, y1 is negative 1, x2 is negative 5, x1 is 2. 3 minus negative 1 becomes positive 4. Negative 5 minus 2 is negative 7. Had you flipped it the other way around, you would have gotten the same answer, and I just want to prove that to you real quick. So let's say instead you did negative 1 minus 3 over 2 minus negative 5. Negative 1 minus 3 gives us negative 4. Negative 2 minus negative 5 gives us positive 7. That's the same answer. We're allowed to put the negative either with the denominator, with the numerator, or you sometimes see it kind of chilling out front. All three of those are equivalent fractions. For the next one, it's the same idea. So you want to write your formula in abstract, just to keep yourself straight. Then it might be helpful to go ahead and label yourself in x2, y2, and x1, y1. And then again, it's plug and chug. So y2 is 4, y1 is 6, x2 is 1, x1 is negative 2. 4 minus 6 gives us negative 2. 1 minus the negative 2 gives us positive 3. In order to write and draw linear functions in slope-intercept form or in point-slope form, usually our first step is that we have to find the slope, and then we need to be familiar with what these forms look like. So slope-intercept form most likely is the form of an equation that you are most familiar with. Y equals mx plus b, where m stands for the slope, b stands for the y-intercept. Because if I were to plug in 0 for x, that mx term would disappear entirely, and I would be left with y equals this b, so there is always a y-intercept at 0, b. And then this m, this slope, tells us how much it is that we're going to be going rise over run each time. How much our y's change as x changes. If you see f of x notation instead, remember y and f of x are just different notations for the same idea. Either way, we're talking about an output. So if I give you an equation already in slope-intercept form, go ahead and pause your video real quick to make sure that you can identify who is the slope and who is the intercept. Our slope in this case is negative 3/4, and our y-intercept is at 0, negative 4. Because again, if I plugged in 0 for x, I'd be left with y equals negative 4. And if you're given something already in slope-intercept form, the easiest way to graph it is just to start at your y-intercept and move according to your slope. So if I was given the line f of x is 1/2 x plus 1, then I would note that my slope is a half, and our y-intercept occurs at the point 0, 1. So that's exactly how we graph it. We start at 0, 1, and then our slope, remember, is change in y over change in x, this little triangle meaning change. So our output goes up 1, and then our input goes over 2. And that is going in the positive direction. This is an increasing line. In order to make a positive slope, there's two different ways you can move. You can either move positive in the y and positive in the x, or you can move negative in the y and negative in the x, since negative divided by negative is positive. So I could, for example, also move down 1, left 2, and that would create another point on my line as well. In order to graph a line, you need at least 2 points, although sometimes it is helpful to make more than 2 just to keep yourself straight on exactly how that line is moving. Go ahead and try to graph the same line that we identified the slope and intercept of earlier. So remember, the slope was negative 3/4, and the y-intercept is 0, negative 4. Go ahead and pause this video and see if you can graph this yourself. It's okay if it's just a sketch on a piece of notebook paper, and then compare with what we get. So we want to start off at the point 0, negative 4, and then we want to move according to our slope. So if we're going to do a negative slope, let's just write that. So negative slope. There's two different directions we can move. We can either move positive on the y's and negative on the x's, or negative on the y's and positive on the x's, because either way, a positive divided by a negative is a negative, or a negative divided by a positive is a negative. So if I move positive on the y's, so up 1, 2, 3, and then negative on the x's over 1, 2, 3, 4, that's one way I can get a second point. I alternatively could have moved down 1, 2, 3 over 1, 2, 3, 4, but if you notice, that's a bit off the page and off my graph. So ideally, I want to pick at least 2 points that are cleanly on my graph. So I would really ignore the one down here, although I'd make a note for myself that that's the direction I expect it to move in. But instead, moving up 3, left 4 actually gave me the overall pattern a little bit cleaner. And just as we noted before, if it has a positive slope, that means it is an increasing function. If it has a negative slope, that means it is a decreasing function. So increasing means from left to right. If I'm walking on top of the line, I'm going uphill. As x gets bigger, y also gets bigger. If it's decreasing, it's the opposite. If I'm walking on top of the line left to right, I'm going downhill. As y gets smaller, x gets bigger, or as y gets bigger, x gets smaller, either way you want to think of it. And then it's constant if it's straight across. So that would look like something like y equals 0x plus 2, but 0 times x is 0, so you're just left with something like y equals 2. Sometimes you have to write linear equations from 2 points, and if one of those points happens to be a y-intercept, the easiest way to write that equation is slope-intercept form. If one of those points is not the intercept, point-slope form is going to be your friend a little bit more, and we'll go over that in just a second. So first thing you want to do is here I was directly given that the y-intercept occurs at 0, 3, but I don't know my slope yet, so I have to find that. So remember, our slope is change in output divided by change in input, change in y over change in x, and I might want to just label for myself quickly what I'm going to personally call x1, y1, and x2, y2. Again, you could flip-flop the order, and that would be fine as long as you stay consistent whenever it comes to plugging it in. That whoever goes first on the numerator has to go first on the denominator. So here I called y2, 3, y1, negative 5, x2, 0, x1, 4, and then I simplify my numerator, then simplify my denominator. So 3 minus negative 5 is 8, 0 minus negative 4 is negative 4, 8 divided by negative 4 is negative 2, and that's my final slope. I probably should not have boxed that in because I should have remembered that we weren't just looking for the slope. Why did we just find the slope? Because we want to actually find the equation. So our equation is y equals mx plus b. I just figured out my slope is negative 2, and they gave me that my y-intercept was 3. So my final equation is y equals negative 2x plus 3. Go ahead and pause the video and see if you can write the next equation yourself. So here they gave us directly that our y-intercept occurs at 0, negative 2, and I need to find my slope. So again, I might find it useful to arbitrarily label my points, although I don't have to do this step if I don't want to. And then I know that my slope is my change in y's divided by my change in x's. On a test or something, I would recommend showing that step just in case all you do is plug things in wrong. y2 in this case is negative 2, y1 in this case is 10, x2 in this case is 0, x1 is negative 6, negative 2 minus 10 is negative 12, 0 minus negative 6 is going to give me positive 6, negative 12 divided by positive 6 is negative 2, and now I want to plug into y equals mx plus b. In this case, m and b happen to be identical, so my slope I just found was negative 2, and my y-intercept given was also negative 2. You also can visually look at a graph in order to write a line in slope-intercept form. If this is the form that you're going to use, I would highly recommend only doing it if you can cleanly see exactly what the y-intercept is on the graph. If you can't, you're going to want to use point-slope form instead, which we'll go over in a minute. So on this graph here, let's go ahead and identify our elements. So we want to identify the slope, and we want to identify the y-intercept. So to identify the slope, I want to look again at that change in y divided by the change in x. So here, according to my graph, between these 2 points, it looks like my change in y is 1, 2, 3. And my change in x is 1, 2, 3, 4. And then I want to note that is this an increasing or decreasing function? Is a decreasing function. I'm going downhill from left to right, so my slope is negative 3/4. If you don't like looking at it visually, we could have alternatively also explicitly plugged it into the formula. If I wanted to label this x1, y1, x2, y2, then my y2 would be 4, my y1 would be 7, my x2 would be 4, my x1 would be 0, 4 minus 7 gives me negative 3, 4 minus 0 gives me 4. Either way, I get negative 3/4. Again, you want to go with whatever is least prone to error for you. If you a lot of times forget the step to make sure that if it's decreasing you make it negative, go ahead and just actually explicitly plug into the formula. If you find yourself making arithmetic mistakes a lot in the formula, but you're able to consistently get from the graph, go ahead and do it from the graph when you can, although still practice the formula, since the formula when you're not given the graph or when the points are funky is still very helpful. And our y-intercept here is at 0, 7, because that is physically where it crosses the y-axis. It's when x is 0. And now I can just plug into slope-intercept form. So y is equal to negative 3/4 x plus 7. Go ahead and pause your video and try this next one. Keep in mind that now our x and y axes are not counting by ones, so you'll want to keep that in mind when calculating your slope. All right, so our slope in this case, I'm going to just show you how to physically still count from the graph. So now our change in y is 2, 4, 6, because I'm counting by 2's. And our change in x is 2, since that is also counting by 2's. And 6 divided by 2 gives me 3, and now I also note that this is an increasing function. From left to right I'm going uphill, so I keep it as a positive 3. Had you accidentally counted by 1's, because the y's and the x's in this case are actually counting by the same thing, you would have been good in terms of that ratio. Had they not been counting by the same thing though, had the x's been counting by 1's and the y's been counting by 2's, you would have gotten the wrong answer. So be careful that you don't do that every time if it's got different axes. And in this case, our intercept occurs at this point here of 0, 2. That's where it physically crosses the y-axis. So if I'm plugging into y equals mx plus b, my slope is positive 3, and my y-intercept is 2. And that is my final equation. Now, a lot of times that y-intercept is not necessarily obvious. It's not given to you, it's not clear from the graph, maybe it occurs at a really funky fraction or decimal, and there's a different form of a line that's a lot easier if that's the case. If you ever think you may take calculus in the future, this form of a line becomes extremely useful, and calculus is going to be a bad time if you don't know it. And in this class, more immediately speaking, we oftentimes explicitly test point slope form exactly, and a lot of times it's not going to be a good time to try to write it in slope-intercept form anyway, or you won't get full credit for doing so. So make sure that you really understand point slope form as well. It works very similarly. M is still my slope, but instead of specifically plugging in my y-intercept, I plug in any random point that happens to exist on the line, and I plug in one of those points, the x value at x1 and the y value at y1. So let's take a look at how we identify these elements if given something in point slope form. So I'm going to find it helpful just to write that formula right underneath it to keep myself straight. And then I want to identify the slope and the y-intercept. Oh, now, I almost messed up there. We were talking about y-intercepts before. We are not given the y-intercept this time. You would have to formally solve for it by plugging in x as 0, and it would be a little bit of math. It wouldn't be too bad, particularly in this case where we don't have funky fractions. We're not wanting the y-intercept, we're just wanting our other random points, which is x1, y1. So here our slope, we notice in the slope position is -4, so our slope is -4, and our points, well, this parenthesis corresponds to x minus x1, so if the result was x plus 3, I must have had x minus a -3. So essentially you end up flipping the sign on him, and so our x1 must have been a -3, because that's the only way I'd end up with a positive 3 here if I'm going from minus. And then our y1, that's a little bit nicer because it's already minus minus, so y1 is just 5. So our slope is -4 and our point is -3, 5. Now let's go ahead and practice writing a line between 2 points. So here, if one point is 4, -5, and the other one is -9, 3, now I need to find my slope first, because we always need a slope regardless if you're using slope-intercept form or point slope form. And then the other difference is you're going to use slope-intercept form if you're using a y-intercept specifically as your point slope form if you want to use some other point. In order to find my slope, that is again change in output over change in input, y2 minus y1 over x2 minus x1. The way I happen to have it labeled here, y2 is 3, y1 is negative 5, x2 is negative 9, x1 is 4, 3 minus negative 5 is 8, negative 9 minus 4 is negative 13. Some of you might be on automatic pilot being like, okay, I'm going to plug in to slope-intercept form and solve for b, which is technically fine. You can do that. But I personally don't want to multiply stuff by negative 8 over 13 and keep track of where it is. So point slope form is going to be a lot nicer here because now there's really very little other work needed. I note the point slope form is y minus y1 equals m parentheses x minus x1. And I'm just going to even leave the same x1, y1 I identified earlier, although I could also use the other point. So y minus negative 5 is my y1 equals negative 8 over 13. X minus 4 is my x1. Minus and negative is a little bit of an eyesore to look at, so I'm going to go ahead and change minus and negative to adding a positive. And otherwise, this is a final answer. That's an equation. No more work needed. Go ahead and pause your video and try to find the line that goes through these other 2 points, and go ahead and make sure to write it in point slope form. First thing I might want to do is label x1, y1 and x2, y2. Then I want to orient myself with the generic formula for a slope is change in y divided by change in x. The way I have this labeled, my y2 is negative 2, my y1 is 10, my x1 is 1, my x2 is 1, and my x1 is negative 6. Negative 2 minus 10 gets me negative 12. 1 minus negative 6 gives me 7. This is yet another example of a slope where I really don't personally feel like solving for the y-intercept. Instead, I'm just going to plug into point slope form. So that gives me y minus my y1 is 10 equals, I actually know what my m is, so I don't need to rewrite m. I know my slope is negative 12 over 7. X minus negative 6 is my x1. You want to make sure that, for example, if I use 10 for my y1, I should use negative 6 for my x1. Had I used negative 2 for my y1, I would have had to use 1 for my x1. And then other than that, all I'm going to do is get rid of the eyesore of minus and negative turns into adding a positive, and I will call it a day. Now, if they want you to make sure it's y equals stuff instead of having a y minus y1, don't freak out. That just means, how do I get rid of subtracting y1? I add y1 to both sides. And so now you have an equivalent form where this is nice and clean. We've got y equals and then a whole bunch of numbers with just an x. And you could even rewrite that in that f of x notation. So this is just a rearranging of point slope form that you may see occasionally. It is possible that you will be asked to write a line through 2 points, and that's given to you in function notation. So if that's the case, if you're wanting to write a linear function with f of 3 equals negative 2 and f of 8 equals 1, my personal first step would be to rewrite this function notation in just like point notation, which I'm a little bit more used to. So this first point, f of 3 equals negative 2, means there's a point at 3, negative 2. F of 8 equals 1 means there's a point at 8, 1. I'm going to go ahead and label this arbitrarily x1, y1, x2, y2, and then I'm going to do the same steps I've been doing. So now I have my slope is equal to y2 is 1, y1 is negative 2, y1 minus negative 2. Actually, I'm going to show that middle step before I start doing that. So remember, slope is y2 minus y1 over x2 minus x1. That I can plug in exactly as I was saying. So y2 is 1. y1 is negative 2, x2 is 8, x1 is 3. So just plugging in the exact same order. 1 minus negative 2 is 3, 8 minus 3 is 5. Now I can plug this into point slope form, so y minus y1 equals the slope, x minus x1. And now I just plug in one of my points. In this case, I'm going to arbitrarily pick the first point because I already labeled that x1, y1. So y minus negative 2 equals 3/5 x minus 3. I'm going to go ahead and change minusing a negative into adding a positive. And even though they didn't make me, if I just want to rearrange this to be y equals stuff, I could subtract 2 from both sides to undo addition. And I would be left with y is equal to 3/5 parentheses x minus 3 with a minus 2 on the outside. And that's a nice, beautiful final form. Go ahead and try the next one yourself. So pause this video and try the next one, and then we'll go over it together. First thing you may want to note is what points were actually given to you. So if I was given f of 2 is -11, that means I have the point 2 comma -11. If I'm given f of 4 is -25, that means I have the point 4 comma -25. And then I might want to again arbitrarily label that x1, y1, x2, y2. So then my slope is change in y divided by change in x. y2 is -25, y1 is -11, x2 is 4, x1 is 2. -25 minus -11, that would get me -14. 4 minus 2 is 2. -14 divided by 2 is -7. So that's actually a relatively nice slope, but I'm still lazy, so I'm going to write it in point slope form. So that's again y minus y1 equals m parentheses x minus x1. I'm just going to keep the same x1, y1 I had before, so y minus -11 equals -7 x minus 2. Plugging in that first point. Minus a negative is the same thing as adding a positive. And again, if I just want it to be y equals stuff, if I didn't want other stuff over there with the y, if I want to rearrange it by subtracting 11 on the other side, you go for it. Then I always could also replace that y with an f of x. Either notation is fine. And that'd be our nice, beautiful final answer. Vertical and horizontal lines come up quite often, and they're sort of special cases. So let's actually derive what those slopes would be. So if we had a line who always had an x-coordinate of -3, so like these were example points on the line, what would be its slope? Let's go ahead and calculate that. So if we have y2 minus y1 over x2 minus x1. Let's go ahead and just pick 2 points that we're going to call x1, y1, x2, y2. So y2 minus y1, that would be 1 minus -5 over -3 minus -3. 1 minus -5 is 6. -3 minus -3, anything minus self is 0. 6 divided by 0, what's the problem? I am not allowed to divide by 0, so this is undefined. So it's undefined if it always has an x-coordinate of -3. What about kind of the other way around? What if it always had a y-coordinate of, and this is a typo, should say -2. I will fix that on your version. Y-coordinate of -2. So these are example points on it. Well, let's actually calculate the slope here. So if we have x1, y1, x2, y2, again, I could have picked a different combination of points as long as I picked 2. So y2 minus y1 over x2 minus x1. y2 is -2. y1 is also -2. x1 is 1. Oh, x2 is 1. x1 is -5. -2 minus -2 is 0. 1 minus -5 is -4. What's 0 divided by anything? 0. And that's exactly how these visually look here. So this is like the first case. If x is always -3, all of these points, we're talking about a vertical line. And what kind of slope did he have again? He had an undefined slope. And then straight across, whenever y was always -2, that was a slope of 0. So these are the pictures you should be having in your head. If x is equal to -3, that means all of these x-coordinates are -3. It results in a vertical line. If y is equal to -2, that means all of those y-coordinates are -2, and it results in a horizontal line. Another way to say an undefined slope would be infinity as well. So let's practice writing these equations. So go ahead and pause your video and see if you can write the equation of each of these lines. So this first one is a horizontal line such that y is always equal to -4. So it's y equals -4. The second one is a vertical line such that x is always equal to 7. So this equation is x is equal to 7. Now let's talk about parallel and perpendicular lines. Those are special types of lines we may be interested in. If they are parallel, that means that they look like this, such that they are side by side, where they have the same steepness and they never touch. So if you notice in the actual equations, what's the same about them? They all have the same slope, but different y-intercepts, and by extension, different points in general. In fact, they never touch, so all of their points should be different, but they will have the same slope. That's the only way that we guarantee that they never touch. If they're perpendicular, that's a different sort of special relationship. So they do actually touch exactly once. That in itself is not particularly special, but what is special is they meet in this nice, beautiful right angle. So if one slope is 3, the other one is -3/1. And remember, 3 is secretly 3/1. So the two slopes are opposite reciprocals. Opposite reciprocals. Which is a fancy way of saying that you're going to both flip the fraction and flip the sign. So for example, flipping the fraction on 3/1 becomes 1/3, and then flipping the sign makes him negative. Same thing the other way around. Flipping the fraction on -1/3 becomes -3/1, and then flipping the sign becomes +3/1. And that's all this is saying in a bit more words, is if they're parallel, they should have the same slope. And if they're perpendicular, they should have opposite reciprocal slopes. Which I just spelled reciprocal wrong, but you can see it was spelled right there. So if, for example, the original slope is -1/4, what's its opposite reciprocal? +4. If the original slope is +2/3, what's its opposite reciprocal? -3/2. If the original slope is -2, what's its opposite reciprocal? +1/2. There is a special case that you just really need to know about and visualize, that vertical and horizontal lines are always perpendicular to one another. So if you want a line that's perpendicular to x equals 4, anything in the format of y equals something else is going to be perpendicular to it. Similarly, what's perpendicular to y equals -2? That's going to be x equals anything, even like x equals 100 is going to be perpendicular to it. So let's say we want to find a parallel line that passes through a particular point. So there are two steps to this. First, we need to actually just figure out what slope we want. Then we want to write the actual equation of a line, most likely in point slope form, because that's typically going to be the simplest form to work with, in that we don't have to solve for any y-intercepts or anything. So first, let's figure out the slope of the original. So if we have 5x plus 3y equals 1, the easiest way for us to figure out its slope is to rearrange this guy so that he does look like he's in slope-intercept form. And by that I mean basically solve for y. So what would I do to solve for y here? Well, first I would want to undo any addition. So in this case, undo adding 5x by subtracting 5x to both sides. 5x minus 5x makes 0. I'm left with 3y equals 1, and -5x are different terms. I'm really just keeping track of where they are and what sign they are. And I'm going to write that specifically as -5x plus 1 because I'm used to seeing the x first. If you wrote 1 minus 5x, that's not technically wrong. It's just that that's kind of backwards to how we're used to seeing it. And 1 minus 5x is the same thing as -5x plus 1. Now as my last step, again, I want to get y by itself. So I divide all three terms by 3. I don't actually care too much about the last term, to be honest, but he is there, so it's worth keeping track of. 3 divided by +3 is 1. So y is equal to -5/3 x plus 1/3. And we did all this work because we wanted to figure out the slope of the original. So what's his slope? His slope is -5/3. And if we want a parallel line, what's the slope of a parallel line? That's going to be the same slope. So it's still going to be negative 5/3. So if we want the entire equation, that would be y minus y1, which in this case would be 5, equals our slope, negative 5/3, x minus x1, which in this case would be 3. And that is our parallel line. What if we want a perpendicular line instead? So first of all, I would normally have to resolve for y if this was a different equation. This is the same equation, so I can just sort of jump to it. What's going to be the perpendicular slope in this case? That's going to be positive 3/5 because we flip the sign and we flip the fraction. We find the opposite reciprocal. Now we actually write the equation. And this time it's through the same point. So we're doing y minus 5 again equals, now we have a new slope, positive 3/5, parentheses, x minus 3 in this case. And that is the perpendicular line. And this is again another case where it really illustrates how much easier it is to work with point slope form. Otherwise I would have to resolve for a different y-intercept on the second scenario than the first scenario, because they will have different y-intercepts. Go ahead and pause your video and see if you can do this next one on your own. Alright, so first thing we want to do is just even figure out the slope of the original. So if we have 5x equals 7 plus y, our goal is to get y by itself. So what's the simplest way to do that? Well, we want to undo adding 7 by subtracting 7 to both sides. So 5x minus 7 is equal to y, which is really no different than writing the equation the other way around. Y is equal to 5x minus 7. So what is his slope? His slope is 5. So now we need to figure out the slope of the parallel line. So what will be the slope of the parallel line then? It would be the same. So it would still be 5. And now we want to plug into point slope form. So that's y minus y1 is negative 2 now, equals our slope, 5, x minus, our x1 is negative 1. And then I may just want to get rid of the eyesore of minus and negative, so that's y plus 2 is equal to 5 parentheses x plus 2. And you're done. That's a nice, beautiful equation of a line. What about the perpendicular slope? So remember, 5 is secretly positive 5 over 1, so our reciprocal would be 1/5, and then we also want the opposite sign, so it's negative 1/5. And now we just actually find our equation, which again is going to be simplest to work in point slope form. So that's y minus y1 equals our new slope, x minus x1. And then again, I might want to change minus and negative to adding a positive. And that's our nice, beautiful equation. Had you formally written it in y equals mx plus b format, that's not wrong. It's just a little bit more work than doing this. Oh, and actually I wrote down something backwards here. Can you notice my little typo? I magically changed minus 1 into plus 2. My bad there. So that's an x plus 1 over there. Let's talk through a few applications. So when we're thinking about applications, we want to think about what information are they giving us. And in particular, we're always on the lookout for any information about a rate of change. And it may be a potential y-intercept or a potential point. So let's take a look at this first example. So suppose Ben starts a company in which he incurs a fixed cost of $1,250 per month for the overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function c where cx is the cost of x items produced in a given month. Now, it might initially throw us off that we've got two different scenarios where there's a per part. But we want to think of which of these is actually talking about how the output is changing with respect to our input. In this case, our input is items produced. It's not actually months. Months is just like a unit of time that we're only caring about here. So this per a month is actually not super important for the sake of our problem. If we were looking at the year and then we wanted to look at how much it changed per month, great. But like the month is just the scenario, it's the setting, but it doesn't have any impact on our math because we only care about what happens in 1 month anyway. And now we want to think if they gave us really a slope and a y-intercept sort of explicitly. And since we're dealing with a y-intercept here, y in this case means kind of a cost. So we're sort of looking at the cost when, and what's our input? So our items are 0. Because our y-intercept is always our output when input is 0. And did they give that to us directly? They actually did, because the fixed cost for overhead, that's how much I have to spend when I haven't produced anything. So that's that $1,250. If we're looking for a slope, that's looking at how much the output changes per one change in input. Since slope is change in output divided by change in input. And did they give that to us? They did. Your costs change by $37.50 each time you produce more items. So our total cost is equal to $37.50 times X plus $1,250. And that's exactly how I would think through these problems. Is for y-intercept, you're looking at some sort of starting point, might be also what would I ask myself in my head. Some sort of starting point is whatever your output is when your input is 0, so whatever your y is when x is 0, if you're using traditional labeling. And for your slope, that should be some sort of rate of change. Something that makes the output change as the input changes. How much does the output change as the input changes? And that's your nice, beautiful final answer there. And that's exactly what these steps are saying. So you want to identify who's an output, who's an input, what's the change in output per change in input. That would be your slope. And then your y-intercept is always your starting point of the output when the input is 0. So let's take a look at that in a new context. So Marcus currently has 200 songs in his music collection, so I'm going to highlight that. Every month he adds 15 new songs. Write a formula for the number of songs in his collection as a function of time, the number of months. How many songs will he own at the end of 1 year? So let's identify our parts here. So we want to identify outputs and inputs. So in this case, what's my output? That would be n, my number of songs. That's what I want to figure out. And what does it change over? What's my input? That is time, in this case t, the number of months. And then we want to figure out if they gave us any of this information directly. So our slope would be a rate of change. So in this case, how many songs change as the months change? Was that given to us directly? It was. It said 15 new songs. And since it adds 15 new songs, that's a positive 15. If I was taking away 15 new songs, I'd make that negative. Our y-intercept, that's going to be our starting point. So that would be how many songs I had before any more time has passed. And was that already given to us? It was. It gave us that Marcus started off with 200 songs. So if we're just writing the equation, that is that our output and our number of songs is equal to 15 times the number of months plus 200. And then what did they ask us to figure out? They wanted to know how many songs he will own at the end of 1 year. Now if I just plugged in 1 for t, what would be the problem? T is measured in months. So by 1 year, how many months actually is that? That would be 12. So I want to make sure I'm plugging in 12 for t and not just 1. Plus 200. And then we just actually want to do out the math. So 15 times 12. Well, 15 times 10 would be 150 plus 15 times 2 is 30. So that gives us 180 plus 200. to give us 380 socks at the end of the year. It's also possible that they don't directly give us either the slope or the intercept, and that I have to do a little bit more work in order to find it. And that's okay. We have all the tools in our toolbox that we can find the slope from 2 points. We can write things in slope-intercept form. Totally fine. So let's see what information is given here. Working as an insurance salesperson, Ilya earns a base salary plus a commission at the end of each new policy. On each new policy. That's how an actual commission works. You earn some sort of base salary and then you kind of kill what you eat. So you get more money as you actually sell more stuff. Therefore, Ilya's weekly income, I, depends on the number of new policies N he sells during the week. So I'm going to go ahead and note that they really just already gave us, without even further information, what our output is and what our input is. What do you think it is? Pause the video and identify it. Our output is our income each week. And our input is N, new policies sold each week. So all points are going to be listed as N, I for that reason, because it's input, output. And then we need to look at what points they really just explicitly gave us in this paragraph. Last week, he sold 3 new policies and earned $760 for the week. So they just told us the point 3, 760 exists on this line. The week before, he sold 5 new policies and earned $920. So 5, $920 also exists on this line. Write an equation for IN and interpret the meaning of the components in the equation. So first, let's actually figure out what our slope is in this case. So what's the slope here? So that's going to be change in income over change in policies, because we're talking about change in Y over change in X. So here, our change in income is going to be 920 minus 760, that's how much our income changed, and then our change in policies is 5 minus 3. So 920 minus 760, that gets us 160. 5 minus 3 gets us 2, so our slope is 80. And even before we write the rest of this, the slope is going to come into play in our equation. Just wanted to see if I had more room to write here. And what we just figured out was, in the way we calculated it, we already kind of interpreted the slope. So that is to say, so I was about to say our, but we have a person here. So Ilya's income increases by $80 when he sells a new policy. That's really what I just figured out by doing this, because I did the change in income divided by the change in policies. I got an average change of 80. So that means that he gets 80 more bucks every time he sells a new policy. Now I want to finish writing the rest of my equation. So I'm going to do the point slope form again. So instead of calling it Y, I'm calling it I. So I minus, pick either one to plug in as your point. I like to deal with smaller numbers, so I'm going to pick the first. 760 is equal to 80. Instead of an X, that's a new policy, minus 3. Here they may want us to rewrite it in slope-intercept form in order to figure out what his base salary is, because I just figured out if his income increases when he sells a new policy, that's our commission. We don't know his base salary yet. So in order to figure out his base salary, I'm just going to rearrange this equation to get income by itself. So I will first distribute the 80. 80n, 80 times 3 is going to get me minus 240. And then I can just add 760 to both sides to get I by itself. So we get that our income is equal to 80 times n, so that's our commission. 240 plus 760 is going to get me plus 520. So his base salary is 520. And another way I would know that is if we plugged in 0 for n, if he sold no policies, he would still have $520. And you could sort of do a sanity check for yourself to double check that like 3 makes sense, for example, in the context of this problem. So if I start with $520 and then I add on 80 times 3, so I add on 240, I should get $760 made, which is exactly what I got. And again, this is how actual sales jobs work, if that's what you end up working after graduation. Or before graduation. So this is slightly more work, but it's the same idea where instead of being able to directly say, hey, this is the rate of change exactly given in the problem, hey, this is our y-intercept exactly given in the problem, you may have to actually find the slope and write the model in order to find those values. So let's look at another example. So town has been growing linearly. That's good because that's the only kind of function we know how to work with as of now. In 2004, the population was 6,200. By 2009, it had grown to 8,100. Assume this trend continues and is asking us to predict the population in 2013 and identify the year in which it'll reach 15,000. In order to make my life easier, I'm going to define the year 2004 as time equals 0 because I'm allowed to do that. I don't have to keep things on the exact same scale. And now with that in mind, let's sort of identify our outputs and our inputs here. So here, since population is changing over time, population is my output. So our population in the town, and our input, and we'll call that population in the town, I don't know, P for population. And our input is years, so I should specify the unit of measurement, years since 2004. And so now I don't need to solve necessarily for my y-intercept. I now know that directly, but I do still need to find my slope. So my slope, remember, is still change in output divided by change in input. So in order to plug that in, let's actually look at what points were explicitly given to us. So they gave us explicitly that when time is 0, there are 6,200 people. And when time is in 2009, that's 2009 minus 2004 is 5 years since 2004. So when time is 5, I had 8,100 people. So our slope is 8,100 minus 6,200 over 5 minus 0. 8,100 minus 6,200, that's going to get us 1,900 divided by 5. 1,900 divided by 5. I'm just going to break out a calculator here real quick because I don't want to mess up my arithmetic right here at the end of the video. That is 380. So the town is gaining 380 people each year. And now we want to predict the population in 2013. So first of all, we need to figure out how many years since 2004 is 2013. So I can just do 2013 minus 2004. 4 minus 13 gives me 9. So it's been 9 years since then. And that's what they want us to plug in for time. So we have our slope. So we gain 380 people a year. We also have our y-intercept. What was our y-intercept again? It was how many people were there in 2004. So our total equation is our population is equal to 380 people times the number of years since 2004 plus 6,200. So in 2013, that would be 380 times 9 plus 6,200. And In terms of order of operations, I first want to figure out what 380 times 9 is. That gets us 3,420 plus 6,200 gives us 9,620 people in 2013. If you want to identify the year in which you'll reach 15,000, now they're giving us what P is, and they want us to find the time. So in order to work the other way around, I'm just going to continue here so I have a little bit more room. We still have 380 times time plus 6,200, but now I'm going to plug in that I want the population to be 15,000 equals 380 times time plus 6,200. And now my goal is to solve for the number of years since 2004. So first I need to undo any addition with subtraction. Then I want to do 15,000 minus 6,200, which gets us 8,800. Equals 380 times time, and that is my final step. I want to undo multiplying by 380 by dividing by 380, which gets us time is 23.16. So is it that the year is 23.16? No, we're measuring since 2004. So this will happen during the year 2027. So it happens partway through the year, that's fine. That's the year that we end up getting up to the 15,000 people. As always, please take a look at your textbook and ask your professor if you have any questions. And I hope you found this video helpful.